my previous video, I promised to explain to you the difference between voltage, current, and power. Why you should stop shouting low current, low current when you discover that your bulb is dim, your electric fan is running slowly, and then why your electrical appliances starts getting burnt. Maybe when NEPA brings light, and so the light is so bright, and your bulb is just boom, boom, boom. Your electric appliances are getting burnt. What's really happened? What is the problem? So I promise to explain all these things in my antecedent video. So if you want to know about those things, watch to the end. Now, take for instance, you have an overhead tank, and the overhead tank is filled with water. Now, before the water can flow, there must be a pressure, a force that will push the water. Now, the higher the pressure, the higher the water that will flow. That means the faster the water will flow. But the lower the pressure, if there is no pressure, even if there is no pressure at all, the water will not move. But if there is pressure, the water will move. And the higher the pressure, the higher the water that will flow. The same thing is applicable to electricity. Take that pressure to be your voltage. If there is no pressure, if there is no voltage, there will not be electricity. And if the voltage is low, that means what you will see will be a low display of electricity. That is why you will see that your fan will be slow, your lights will look dim. Now, take that water that flows through your pipe to be the electricity that flows, to be the current. So the current is now the amount of electricity that flows through the pipe. They take the pipe as your wire. So the pipe is your conductor, the wire. So the current will flow, the electricity will flow through your wire. Then it will go into your appliances. Now let's talk about power. Power is the combination of both the current and the voltage. Moving back to that the water tank that I cited as an example the other time. Take the power as the work done. So the combination of that pressure and the water that flows will now produce the water that will go into your bucket or that will make use of. So it is that power that makes your fan to be rotating, that makes your lights to shine, that makes your electrical appliances to start working. So if you notice, most of your appliances are rated in watts because power is rated in wattage, voltage is rated in volts, then current is rated in ampere. If you check your appliances, you will see the labeling there. Through the labeling, you will see something like 5 watts. For instance, this bulb is rated 5 watts. This pressing iron is rated 2,500 watts. So the amount of power that this one will take is much more greater than this one. So, and I told you the other time that power is the combination of both the voltage and the currents. So that means this one is consuming higher current but the same voltage. Why? Because from that NEPA that you are talking about, they supply the same voltage. So it is not when the voltage gets to your socket and you're about to plug the appliances, it is your appliance that will now determine that, okay, this is the amount of current I want to draw. So it's not the fault of the NEPA. They supply voltage. So the same voltage is correct, but your appliance will now be like, me, I'm taking 2 amps, I'm taking 5 amps. Your charger will just draw 2 amps of current. This one will draw less than 1 amp. Imagine the amount of current this one will draw. 2,500 watts. That is why when you plug it, you see the effect through your lightning. So it is not the fault of the current, it is the fault of the voltage. So when the supplied voltage is low, that is when you now discover that your lights becomes dim, your fan will be running slowly, and you will see the effects at your house. So in your house, you see the effects. So it is not the fault of the current, but the effect of the voltage. So as from today, I don't want to be hearing anybody saying that NEPA, low current. Say the right thing. That is why I'm here for you, and I've explained. So after this explanation, I don't want to be hearing anybody saying that low current. It is low voltage. Your appliances is the one that draws the current that you want, but NEPA supply you with either high voltage or low voltage, or the accurate one. And sometimes you just discover that, oh, the light is too bright. You can say that this one is too bright than normal. That means the voltage is high. That's why you discover maybe sometimes you just hear boom, boom. Your bulb is blowing, your appliances are getting burnt, and things like that. That is when the voltage is high. And by the time you plug your appliances there, you will discover that the normal current that your appliance is supposed to draw is drawing more than that. It's drawing more than that. It's drawing more than it can take. That is why it gets burnt. So the same thing, when the voltage is low, your appliances will not be able to get the normal current it's supposed to get because the voltage is low. So henceforth, If I should hear anybody shouting low current again, I'm going to sue you. Don't worry, I'll sue you. I'll get my lawyer. I'll tell them to sue you, because even after all this explanation, you're still saying the wrong thing. I'll make sure I get you arrested. Don't say I did not tell you. Tell that Baba landlord henceforth, so that he will take note of that.